Jesus is one of fewer than 24 works attributed to Renaissance master Leonardo da Vinci. But in a new book, one author paints a different picture. He questions whether the painting is a genuine Leonardo and if its incredible sale price was really the result of some...
For 500 years, his biological secrets were buried, lost forever. Or so we thought. After decades of desperate searching, researchers finally unlocked the truth hidden in his genetic code. But when the results came back, they couldn't believe their eyes. What they discovered was so shocking, so unexpected, that it threatens to rewrite history itself.
And they added in, they say, we still only did the minimum, but,
What did you find as to why they would want to make it live again?
it would be impossible to achieve the highest possible price for this Leonardo without giving it a thorough market restoration.
The man we thought we knew never actually existed. And what's been hiding in his bloodline all along will make your blood run cold. This changes everything. When most people think of Leonardo da Vinci, they picture the Mona Lisa or maybe the Last Supper. These masterpieces have defined our understanding of artistic genius for centuries. But focusing only on his paintings misses the bigger picture. Leonardo was so much more than an artist. He dissected human bodies to understand anatomy. He designed weapons and fortifications for powerful rulers. He sketched helicopters and submarines centuries before anyone could build them. His notebooks overflow with ideas that seem impossibly advanced for someone living in the 1500s. Yet despite all this fame, the man himself remains mysterious. Historians have spent generations piecing together fragments of his life from old letters, payment records, and those famous notebooks filled with mirror writing. But there's always been something missing. The most fundamental layer of who he was, his biological identity, has stayed locked away. Unlike other famous figures from the Renaissance, Leonardo didn't leave behind children to carry on his bloodline. He never married. He worked in Florence and Milan, served dukes and kings, traveled across Italy and France. But when it came to his DNA, the trail went completely cold. This has frustrated researchers for a very long time. And it's not just about curiosity for the sake of curiosity. Understanding Leonardo's genetic makeup could answer real questions about his life. Take his famous mirror writing, for example. He wrote backwards, from right to left, so you need a mirror to read his notes easily. Was this connected to left-handedness that might have run in his family? What about his incredible stamina? The man worked on multiple massive projects at once, often through the night. Could there have been genetic factors that gave him unusual energy or focus? And his attention to detail was legendary. He'd spend years perfecting a single painting. Some researchers wonder if there might be genetic markers that influenced his personality or capabilities. These aren't idle questions. The answers could fundamentally change how we understand genius itself. But for centuries, all of this remained pure speculation because there was simply no biological material to test, no body to examine, no DNA to analyze. The problem sounds simple, but solving it has been anything but. Where exactly do you find DNA from someone who died in 1519? Leonardo was buried in Amboise, France, but his grave was disturbed centuries ago during the French Revolution. The chapel where he was laid to rest was actually destroyed. When people tried to recover his bones in the 1800s, they found remains scattered and mixed up. Nobody could say with certainty which bones, if any, actually belonged to him. Over the years, various hairs and relics have surfaced with claims of being Leonardo's, but proving authenticity has been impossible. That left researchers with one possibility. If Leonardo didn't have children, maybe the answer lay somewhere else in the family tree, specifically through the male line. This is where genetics offers something remarkable. The Y chromosome, which determines biological maleness, passes from father to son with very little change. Unlike most of our DNA, which gets shuffled and mixed with each generation, the Y chromosome stays largely the same across centuries. This means if you could trace Leonardo's family through the male line, you might be able to find living relatives today who carry essentially the same Y chromosome he had. It's like a genetic thread connecting the present directly to the past. The idea was brilliant in theory, but seemed almost impossible in practice. It would require going through hundreds of years of records, finding documents that might not even exist anymore, and building a family tree across more than 20 generations. Most families can barely trace their ancestry back a few generations. Doing this for someone from the 1400s seemed like a fantasy, but a small group of dedicated researchers refused to give up. Two specialists in Leonardo's history, Alessandro Vezzosi and Agnese Sabato, started what would become a 30-year project. Their goal was straightforward, but monumentally difficult. Could they actually map out Leonardo's entire extended family across 6 centuries? Could they find living descendants connected through the male line who might still carry his genetic signature? They started in Vinci, the small town in Tuscany that gave Leonardo his name. This is where the detective work really began. Parish records, baptismal certificates, marriage contracts, property deeds, notary documents. Every scrap of paper from the 1500s onwards became a potential clue. A father's occupation here, a brother's name there, a widow's inheritance document, a land sale. Each piece of information connected one generation to the next. It was painstaking work, vulnerable to all the gaps left by wars, fires, floods, and simple decay over hundreds of years. But slowly, generation by generation, a picture started to emerge. The Da Vinci family tree began to take shape. Branches that had been forgotten for centuries suddenly reappeared. Names of men who lived and died in obscurity were brought back into history. While Leonardo himself never had children, his father did. Leonardo had half-brothers and half-sisters, and they had families. The bloodline didn't end with Leonardo. It just continued quietly through relatives that history had largely ignored. What makes all of this so important is that it created a framework, a map. For the first time, geneticists had something to work with. If they could identify living descendants of Leonardo's relatives, particularly through the unbroken male line, they could potentially test their DNA. And if those descendants shared a matching Y chromosome pattern, it would mean that genetic signature had been passed down from Leonardo's time to the present day. That signature could then serve as a stand-in for Leonardo's own DNA. It wouldn't be perfect, but it would be closer than anyone had ever come before. For generations, Leonardo da Vinci has existed more as myth than man. His genius seems almost supernatural, as if he was dropped into the Renaissance from some future era. But behind the legend was a real human being with a family, with ancestors, with blood relatives. Reconstructing his DNA isn't just about satisfying curiosity. It's about pulling him back from myth and placing him firmly in the human story where he belongs. The implications are staggering. Imagine being able to say with confidence, not just what he painted or invented, but what diseases he might have been prone to, what physical traits shaped his appearance, how his genetic makeup might have influenced his extraordinary mind. For the first time in history, that possibility seemed within reach. The biological Leonardo, lost for so long, was starting to come back into focus, and the journey to find him was only just beginning. The search for Leonardo da Vinci's DNA might sound like a project born in a high-tech genetics laboratory, but the truth is far different. The real work began not with microscopes or test tubes, but with old documents, faded ink, and archives that hadn't been touched in decades. If the biological trail had gone cold, maybe the paper trail could light the way forward. This was the thinking that guided 2 Italian historians who would dedicate more than 3 decades of their lives to what seemed like an impossible task. Alessandro Vezzosi and Agnese Sabato weren't geneticists or forensic scientists. They were historians who specialized in Leonardo's life and legacy. But they understood something crucial. If you want to find someone's DNA after 500 years, you need to understand their family. Not just their immediate family, but the entire sprawling network of relatives stretching back through the centuries. And that meant going deep into the archives. The challenge they faced was enormous. how do you reconstruct the family tree of someone who lived in the 1400s, left no children, and whose own remains couldn't be reliably identified? Most people struggle to trace their family back 3 or 4 generations. Vezzosi and Sabato were attempting to go back more than 20. They would need to find birth records, marriage certificates, death notices, property transfers, and legal documents for hundreds of people across 6 centuries. Many of these documents would be damaged, incomplete, or simply lost forever. They began their work in Vinci, the small Tuscan village where Leonardo was born in 1452. This wasn't just symbolic. Vinci was where the paper trail started. The town kept parish records going back to medieval times, and these dusty ledgers became the foundation of everything that followed. Each baptismal certificate told them about a birth. Each marriage contract revealed new family connections. Notary documents showed property changing hands between relatives. Death records confirmed who had lived and when they had died. But this wasn't simple data collection. Every document had to be cross-referenced with others. A name mentioned in one record had to match up with a name in another. Dates had to align. Relationships had to make sense. It was like assembling a massive jigsaw puzzle, where most of the pieces were missing and some might not even belong to the same puzzle. The work demanded extraordinary patience and attention to detail. A single mistake early in the chain could throw off everything that came after. The researchers moved methodically through the centuries. They started with Leonardo's father, Ser Piero da Vinci, who was a notary. Ser Piero had multiple wives and at least 12 children, though Leonardo was born outside of marriage to a woman named Caterina. Leonardo's legitimate half-siblings became crucial to the project because they carried the same paternal lineage. Their children and grandchildren formed the branches of the family tree that would eventually lead to living descendants. One of the key figures they tracked was Domenico, one of Leonardo's half-brothers. Domenico's line proved particularly important because it could be traced forward through multiple generations. Each generation added new names, new births, new marriages. Some branches of the family stayed in Tuscany. Others moved to different parts of Italy. A few disappeared from records entirely, lost to migration, early death, or simply incomplete documentation. But enough survived to create a continuous thread. What makes this research remarkable isn't just its scope, but its accuracy. Vezzosi and Sabato ultimately reconstructed a lineage covering 21 generations and involving more than 400 individuals. This wasn't a simple straight line from father to son. It was a complex, branching network showing how one family spread and evolved over 600 years. They documented farmers, craftsmen, merchants, and professionals, people who lived ordinary lives completely unaware that they were connected to one of history's greatest geniuses. The breakthrough moment came when they realized their genealogical work could actually connect to modern genetics. For years, they had been building this family tree purely as historical research. But as DNA science advanced in the late 20th and early 21st centuries, the potential application became clear. If they could identify living men who descended from Leonardo's relatives through an unbroken male line, those men would carry the same Y chromosome that had been passed down from Leonardo's father. This is where understanding the Y chromosome becomes essential. Unlike the rest of our genetic material, which gets mixed and shuffled with each generation, as we inherit half from our mother and half from our father, the Y chromosome passes from father to son almost unchanged. Mutations happen, but they're rare and usually minor. This makes the Y chromosome an incredibly powerful tool for tracing family lines across vast spans of time. If a particular pattern or signature exists on the Y chromosome, it acts like a genetic fingerprint that survives through the centuries. The researchers began the delicate work of moving from historical documents to living people. They identified surnames that appeared consistently through the generations. They tracked down families still living in Italy who might be connected to this ancient lineage. This required not just historical knowledge, but also diplomacy. These were ordinary people being told they might be related to Leonardo da Vinci. Some were skeptical, some were excited. All had to be approached carefully and respectfully. Eventually, Vezzosi and Sabato identified a group of men whose ancestry could be traced directly back through Leonardo's paternal relatives. These weren't claimed descendants or family legends. These were individuals whose lineage could be documented step by step through centuries of records. The genealogical proof was solid. Now the question was whether the biology would confirm what the documents suggested. The next phase required the cooperation of these families. The researchers needed DNA samples, which meant asking these men to provide cheek swabs for genetic analysis. This was asking a lot. They were being invited to participate in a scientific project that would examine their most personal biological information. But the historical significance won them over. 15 men eventually agreed to participate, 15 living links to the Renaissance. This was more than just a scientific milestone. It was a human moment. These men, living normal lives in modern Italy, were about to become part of a story that stretched back to Leonardo himself. They weren't his direct descendants, of course, but they were family nonetheless, connected through the unbroken chain of fathers and sons going back more than 20 generations. By the time Vezzosi and Sabato published their detailed findings, the genealogical puzzle was essentially solved. They had proven that Leonardo's family line didn't die out, as many had assumed. It survived, quietly and unremarkably, through centuries of ordinary people. More importantly, they had created a roadmap that geneticists could now follow. The paper trail was complete, the family tree was documented. The living descendants were identified and willing to participate. What had seemed impossible 30 years earlier was now real. The genealogical framework was in place, ready to be tested against actual DNA. For the first time in history, the idea of finding Leonardo's genetic signature had shifted from fantasy to achievable scientific goal. The archive work was done. Now it was time for the laboratory to take over. The quest across centuries had accomplished something extraordinary. It had proven that even though Leonardo left no children, he didn't vanish biologically. His family endured, carried forward by half-brothers and their descendants who never imagined the weight of their heritage. And that discovery changed everything about what came next. If genealogy provided the roadmap, then biology was supposed to deliver the treasure. For all the excitement generated by reconstructing Leonardo da Vinci's family tree across 21 generations, the real challenge still lay ahead. It wasn't enough to show that his relatives existed on paper. Researchers needed actual genetic material that could be linked, either directly or indirectly, to Leonardo himself. This is where the investigation transformed from historical research into something closer to a forensic detective story, spanning museums, libraries, family tombs, and cutting-edge laboratories. The first question facing the team was straightforward, but incredibly difficult to answer. Where might traces of Leonardo's DNA still exist after more than 500 years? His burial site in Amboise, France presented immediate problems. Leonardo died in 1519 and was buried in the chapel of Saint Florentin at the Château d'Amboise. But that chapel was destroyed during the French Revolution in the late 1700s. When 19th century researchers tried to locate and recover his remains, they found a chaotic situation. Bones were scattered, mixed together, and poorly labeled. Some skeletal remains were eventually reburied in the chapel of Saint Hubert nearby, with a plaque declaring them to be Leonardo's. But whether those bones actually belonged to him remained deeply uncertain. This uncertainty created a massive obstacle. You can't simply dig up what might be Leonardo's grave and expect reliable results. If the bones don't belong to him, any DNA analysis would be worthless. Even worse, testing would destroy precious material that might have historical value regardless of whose bones they actually are. Scientists needed other options, other sources of potential DNA that could be verified independently. Attention turned to various relics and artifacts attributed to Leonardo over the centuries. Hair samples occasionally surfaced in private collections, often with elaborate stories about their origin. In 2019, a lock of hair claimed to belong to Leonardo was revealed in an American collection. According to the story, this hair had been brought from France over a century earlier and carefully preserved. The announcement made headlines around the world. Finally, it seemed, there might be direct biological material from Leonardo himself. But excitement quickly gave way to skepticism. The problem with relics like this is provenance, the documented history of where something came from and who owned it through the years. Without clear, unbroken provenance, a lock of hair could belong to absolutely anyone. It could be from another person entirely, or even from multiple people if strands got mixed together over time. Hair samples are particularly tricky because they were popular souvenirs in the 18th and 19th centuries. People collected hair from famous figures, or at least hair they claimed came from famous figures. Proving authenticity after so many years is extraordinarily difficult. The same problems apply to Leonardo's manuscripts and notebooks. These documents are priceless, filled with his mirror writing, technical drawings, and personal observations. In theory, they might contain traces of his DNA, sweat from his hands, skin cells shed while turning pages, perhaps even saliva if he licked his finger to turn a page or tested a pen on his tongue. But here's the catch. These manuscripts have been handled by countless people over 5 centuries. Collectors, scholars, curators, conservators, thieves, and curious visitors have all touched these pages, their DNA mixed with whatever traces Leonardo might have left behind. Separating his genetic material from all that contamination would be like finding a specific grain of sand on a beach. Each supposed lead raised hopes and then crashed into practical obstacles. Researchers began to realize they needed a different strategy. Rather than chasing after Leonardo's direct remains or relics of questionable authenticity, perhaps they should focus on his relatives. This is where the genealogical work by Vizzosi and Sabato became absolutely crucial. If they couldn't test Leonardo directly, maybe they could test members of his family and you'll use that information as a reference point. The focus shifted to Vinci, the Tuscan town where Leonardo was born. Researchers knew there was a family tomb there, believed to contain remains of Leonardo's father, Ser Piero, and several of his half-brothers. If bones could be recovered from this tomb, and if DNA could be successfully extracted, those results could be compared with the living descendants identified through genealogical research. A match would confirm that the bones truly belonged to the Da Vinci family. More importantly, it would establish a verified genetic signature that could later be used to test any remains or artifacts claimed to be Leonardo's. Archaeological work began at the site. Excavating old tombs is delicate work, requiring careful documentation of every layer, every fragment. The goal isn't just to find bones, but to preserve as much context as possible. When bone fragments were recovered, they appeared to belong to men of the right age and time period based on the burial site and surrounding evidence. But appearance isn't proof. The fragments needed to go to a laboratory for proper analysis. This is where forensic anthropology entered the picture. Specialists like Elena Pilli and David Caramelli from the University of Florence took on the painstaking work of extracting DNA from these ancient bones. Anyone who thinks this is simple doesn't understand how fragile old DNA can be. After centuries in the ground, exposed to moisture, temperature changes, and bacterial activity, DNA degrades into tiny fragments. Sometimes only partial sequences survive. The extraction process requires working in extremely clean laboratory conditions to avoid modern contamination. Researchers essentially work in sealed rooms, using sterilized tools, often wearing protective suits. They're trying to recover genetic information from samples that might contain only microscopic traces of usable DNA. The process involves crushing small amounts of bone into powder, using chemical treatments to break down the remaining organic material, and then amplifying whatever DNA fragments can be recovered. It's time-consuming and doesn't always work. Many samples yield nothing usable at all, but when it does work, the results can be extraordinary. Even partial DNA sequences can be compared with reference samples to determine family relationships. Meanwhile, the living descendants identified by Vizzosi and Sabato provided their own DNA samples through simple cheek swabs. This modern DNA was easy to work with, complete and uncontaminated. The question was whether it would match the ancient DNA from the family tomb. If the Y chromosome patterns aligned, It would prove biological continuity across more than 20 generations. It would confirm that the genealogical research hadn't just tracked names on paper, but actual genetic inheritance. Beyond the family tomb, researchers continue to explore other possibilities. Advances in DNA extraction technology have made it possible to recover genetic material from objects without destroying them. Techniques exist now that can lift microscopic traces from paintings, manuscripts, or tools. Imagine being able to swab the edge of one of Leonardo's notebooks and actually recover his DNA from the oils in his fingerprints, or finding traces in the binding of a book he handled frequently, or even detecting DNA in pigments he mixed himself, since Renaissance artists often worked directly with their materials in ways that would transfer biological material. These aren't fantasies anymore. They're realistic scientific possibilities, though incredibly challenging to execute. The problem remains contamination. Even with the most careful techniques, distinguishing Leonardo's DNA from everyone else who touched these objects over 5 centuries requires extraordinarily sophisticated analysis. But if researchers could find even a partial match between genetic traces on his works and the verified Y chromosome signature from his relatives, it would provide unprecedented confirmation of his biological identity. The hunt for biological evidence wasn't driven purely by curiosity. Real questions about Leonardo's life hung in the balance. Historical accounts describe him suffering some kind of paralysis late in life, possibly a stroke that left his right hand weakened. Genetic analysis might reveal whether he carried markers for vascular disease or other conditions. There were questions about his physical appearance too. Contemporary descriptions exist, but they're vague and sometimes contradictory. DNA might help reconstruct aspects of his looks, from eye color to hair color to facial structure. There were also implications for art history. Several paintings attributed to Leonardo remain disputed. Did he paint them entirely himself, or did students and assistants do much of the work? If DNA could be recovered from these works and compared with the verified family signature, it might help settle centuries-old debates about authenticity and attribution. What started as an abstract search for lost DNA had become a concrete scientific project combining archives, archaeology, and genetics. The pieces were starting to align in ways nobody had quite anticipated. Living descendants with documented lineage were providing reference DNA. Bone fragments from family members were yielding ancient genetic material. And the possibility of testing manuscripts and artworks loomed on the horizon. The biological evidence wasn't all in hand yet, but researchers had moved further than anyone thought possible even 20 years earlier. The mystery was no longer whether Leonardo's DNA could be found, but rather how all these different pieces would fit together to complete the picture. For decades, the search for Leonardo da Vinci's DNA seemed destined to remain forever incomplete. It was the kind of historical puzzle that fascinated people, but never seemed likely to have a real solution. But in recent years, something remarkable happened. After all the genealogical groundwork, after years of painstaking archival research, the decisive moment finally arrived. 6 living men, each one traced back through 21 generations of Da Vinci family history, agreed to provide DNA samples for scientific analysis. What researchers discovered next was nothing short of extraordinary. The entire focus of the analysis centered on the Y chromosome, that genetic thread passed from father to son across the centuries. Unlike most of our DNA, which gets shuffled and recombined with each generation, the Y chromosome remains largely stable. It's a direct line of inheritance that can stretch back hundreds of years with relatively few changes. When scientists compared the Y chromosome data from these 6 men, they found something remarkable. Key segments matched across all the samples. This meant the genetic continuity of the Da Vinci male line had been preserved for over 600 years. The statistical probability of this happening by chance was incredibly small. These weren't just similar patterns. These were matching genetic signatures that could only exist if the men truly shared a common ancestor through an unbroken male line. The family story that began with faded documents and dusty archives now had the backing of modern molecular biology. The paper trail had been proven correct by the biological evidence, but the discoveries didn't stop there. Remember those bone fragments recovered from the Da Vinci family tomb in Vinci? Forensic specialists at the University of Florence had been working on those remains, carefully extracting whatever DNA could be recovered from centuries-old skeletal material. The results confirmed that at least one of the skeletons was male and dated to the correct historical period. Now comes the critical question: did the DNA from these bones match the same Y chromosome pattern found in the living descendants? When the comparison was made, the answer was yes. The genetic signature matched. This was the breakthrough everyone had been waiting for. Researchers now had scientifically verified Da Vinci family DNA from both the past and the present. The continuity was proven beyond doubt. More importantly, this verified genetic signature could now serve as a reference point. Any future attempts to identify Leonardo's own remains, or to test relics and artifacts claimed to be his, could be compared against this established family marker. What makes this discovery so significant is its dual nature. On one level, it closed a door that had frustrated historians for centuries. The Da Vinci family line was no longer a mystery. The genetic continuity had been demonstrated, documented, and verified. The question of whether Leonardo's bloodline survived into the modern era was answered definitively. It did survive, carried forward through half-brothers and their descendants across more than 20 generations. On another level, the discovery opened entirely new doors. With a verified genetic marker in hand, researchers now possessed a powerful tool. Disputed artworks could potentially be tested for DNA traces and compared with the family signature. The controversial bones in Amboise could finally be examined with a reliable reference point. Even manuscripts and drawings might yield genetic evidence that could be matched against the verified pattern. For the first time, science had given historians a way to potentially confirm or rule out biological connections to Leonardo with real certainty. The implications reach far beyond simple curiosity about a famous artist. Understanding Leonardo's Y chromosome might eventually help reconstruct aspects of his health and physical characteristics. It could reveal genetic predispositions that influenced his life. The paralysis he reportedly suffered in his final years, for instance, might be linked to hereditary vascular conditions. Even questions about his extraordinary abilities, while never reducible to genetics alone, might gain new context from biological analysis. The discovery also has profound implications for art authentication. For centuries, experts have relied on style analysis, brushstroke patterns, and historical documentation to attribute works to specific artists. Now there's a potential new tool in the toolkit. If DNA can be recovered from a painting or drawing and matched to Leonardo's verified family signature, it adds a level of scientific certainty that traditional methods can't provide. This doesn't replace expert analysis, but it complements it in powerful new ways. Perhaps the most striking aspect of this entire story is how it unfolded. Most people imagined the DNA mystery would be solved by finding Leonardo's actual skeleton, testing his bones, and getting a clear result. That's the Hollywood version of scientific discovery. But reality turned out to be far more interesting and more complex. The solution came not from opening a single tomb, but from proving biological continuity across 6 centuries. It came from the patient work of historians, who spent 30 years reconstructing a family tree. It came from living men who never suspected their ancestry connected them to Renaissance genius. It came from forensic scientists carefully extracting fragments of ancient DNA from family tombs. It came from the convergence of multiple lines of evidence, all pointing to the same conclusion. The DNA mystery of Leonardo da Vinci has been solved, though not in the way most people anticipated. There's no single dramatic moment of opening a coffin and holding up a skull. Instead, there's a network of evidence, a web of connections between past and present, between documents and DNA, between the dead and the living. It's a reminder that history rarely delivers neat, simple answers. The truth is usually more complicated, more nuanced, and ultimately more fascinating than we expect. What began as an effort to answer a scientific riddle has transformed into a story about connection. It's about the invisible threads that link us to the past, the genetic inheritance that travels silently through generations, and the persistence of family across time. Leonardo may have died childless in 1519, but his bloodline didn't end with him. It continued quietly, unremarkably, through ordinary people living ordinary lives. And now, more than 500 years later, that connection has been proven and documented. The legacy of this genetic revelation extends beyond Leonardo himself. It demonstrates what's possible when different fields work together, when historical research meets cutting-edge science, when patience and persistence overcome seemingly impossible obstacles. The Da Vinci DNA Project has become a model for how we might approach other historical mysteries. It shows that even after centuries, even when the trail seems completely cold, answers can still be found if we're willing to look in the right places and ask the right questions. Leonardo's genius may never be fully explained or replicated, but his biological legacy has been recovered and verified. His place in the human story has been confirmed not just through his art and inventions, but through the genetic code that defined his physical existence. And that code, remarkably, hasn't vanished. It's still here, still alive, carried forward in the bodies of people who walk the earth today. That might be the most profound discovery of all.